So then the last type of proportion question I'll ask you is dealing with similar triangles. So in a similar triangle, what will happen is that all three angles will be the same, which will make their side lengths proportional to each other. So what we have to do is set up a proportionality statement. So you could say something like side AB is proportional to AC, like PQ is to PR. Okay, that would be one example of proportionality statement. So you could say 4 is to 7 as x minus 10 is to x plus 5, because those are the side lengths that would be proportional to each other. So from single line to double line, single line to double line, single line to there, single line to there. That is one proportionality statement you could solve. You could also say that 4, so AB, is to PQ, so 4 is to x minus 10, right? As maybe 6 is to x. That would be another example of a proportionality statement you could solve. You could set up another one, saying that 7 is to x plus 5 as 6 is to x. You could keep them, so the moral of the story is you can keep it within the same fraction, so this, or same triangle, so this triangle is proportional to this triangle, so 4 is to 7 as x minus 10 is to x plus 5, or you can go between the two triangles. So 4 is to x minus 10 as 7 is to x plus 5, or what I wrote, 4 is to x minus 10 as 6 is to x. Any proportionality statement that you set up will solve and give you the same answer. So I've got two different proportionality statements. You could pause the video and choose one of them to solve, or you can keep following and I'll maybe solve both of them. So let's do this one first. The lowest common denominator for this one would be 7 times x plus 5. So I'm going to multiply this guy by 7 times x plus 5. I'm going to multiply this one by 7 times x plus 5, and then I'm going to destroy. So the 7 goes, the x goes, or x plus 5. I'm left with 4 times x plus 5 is equal to 7 times x minus 10. To solve this, I'm going to simplify by multiplying through. Then I'm going to put my x's on one side to give me 20 equals 3x minus 70. Then I'm going to get my x term by itself. And then I'm going to divide to get x by itself. I end up with 30 is equal to x. If I had solved this proportionality statement, my lowest common denominator would be x times x minus 10. So I would multiply both terms by x times x minus 10. And then again, gone, 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 gone. I'd be left with 4x is equal to 6 times x minus 10. Multiply through. I get 6x minus 60. This one I'm just going to put my x's on the left, less to move. I get negative 2x equals negative 60. Divide both sides by negative 2, and I get x equals 30. So again, doesn't matter how you set up your proportionality statement, what we'll get is that x equals 30. Then you have to see what they're asking you to solve for. Sometimes they just want to know what x is. Sometimes they want to know what the unknown lengths in your triangles are. So if they want to know that, my three lengths are x, x minus 10, and x plus 5. So x, x minus 10, and x plus 5. So my three lengths would be 30, 30 minus 10, which is 20, and 30 plus 5, which is 35. So something along those lines as a therefore statement, just showing me that you've solved the similar triangles. Awesome. That is the end of chapter 6.